Hello, Assalamu alaikum. I'm Sudhir Kochakma. So today my topic is designing data intensive application, and I'm going to talk about the topic data model and query languages from chapter 2. So this is the main concept map from the data model and query languages. So let's talk about relational model versus the document model. So the goal of relational model is to hide implementation details behind a clean interfaces. So in SQL we have a relational database management system, and SQL became the tool of choice around mid 1980. So a relational model turned out to generalize view well. So the birth of NoSQL. So NoSQL just a catchy hashtag on Twitter for a meetup. NoSQL is the latest attempt to overthrow the relational model dominance. So driving forces for NoSQL and need for better scalability dataset and performance for free and open source software, and then specialized query operations that are not supported by the relational model, and the restrictionness of the relational schemas. It's likely that relational database will continue to be used along with many databases. So let's talk about the object relational mismatch. So uh, there are some mismatches that we have to deal with. The first one is normalized databases with foreign keys. Then use a database that supports for structured data, and then encode as JSON or XML and store as text in databases. It cannot be queried this way. Store as JSON in document oriented databases like MongoDB. This has better quality than the normalized representation. So now let's talk about one to many and many to many relationship. So we can say using IDs reduce duplication, and this is the key idea behind normalizing databases. Yet this requires a many to one relationship, which may not work well with document databases whose support for joins are weak. So are document bases repeating history? Yes. In 1970, the IBM's information management system also used a hierarchical model similar to the JSON model. Data was represented as a tree of records nested within records, and the network model and relational model was postponed to solve the limitation of the hierarchical model. So now let's talk about the network model. So here is the network model. So network model is also known as conference on sorry. So network model is also known as conference on data system languages model. The network model allows multiple parents for each record. The line between records were not foreign keys but more like pointers which a user can follow through. A query is done by moving a cursor through the database by iterating over listed of records and following access paths. Although it made the most efficient use of the hardware, the model made querying and updating the database complicated and inflexible. So let's talk about the relational model. So the relational model is simply a relation and a collection of tuples, like in table, rows, and columns. In a relation database, the query optimizer automatically decides how to efficiently execute the query, where the developer has to decide the access part in network model. So let's talk about a comparison to document databases. For one-to-many relationship, document databases are similar to hierarchical model in that they stored nested record within their parents record rather than separated records. So now let's talk about query languages for the data. We know SQL is a declarative query language, while information management system and CODAY as well, like I said before, are queried by imperative code. In a declarative language, only the goal is specified and not how the goal is achieved. It hides implementation details and leaves room for performance optimization. The fact that SQL is more limited in functionality gives databases more room for automatic optimizations. Declarative code is easier to parallelize as execution order is not specified. So what is declarative queries on the web? So we can say CSS and XSL are declarative languages to specify styling in HTML. We all know HTML, hypertext markup language. While changing style directly through JavaScript is imperative. So let's talk about the map reducing query. So MapReduce is a programming model for processing large amount of data in bulk across many machines, and a limited form of MapReduce is supported by MongoDB and CouchDB. MapReduce is somewhere between declarative and imperative. SQL can but not necessarily have to be implemented by MapReduce operations. Sorry. MongoDB supports a declarative query language called aggregation pipeline, where users do not need to coordinate a map and reduce functions themselves. So now let's talk about the graph, which are like the data models. So now we are going to talk about this part, and this part is an application with mostly one-to-many relationship or no relationship between records. The document model is appropriate, but for many-to-many relationship, graph models are more appropriate. Graphs can be homogeneous, where all vertices represent the same type of object, and heterogeneous, where vertices may represent completely different objects. And property graphs. So what are the main property graphs? So each vertex consists of a unique identifier, a set of outgoing edges, a set of incoming edges, and a collection of properties. So each edges consists of a unique identifier, the vertex at which the edges start, the vertex at which the edges ends, a collection of properties. So the property graph model is analogs to storing two relational databases, one for vertex and one for edges. So multiple relationships can be stored within the same graph by proper labeling the edges. Graphs can easily extend to accommodate new data types. So now let's talk about the Chyper query languages, which is also content property graphs. This. So basically the Chyper query language is a declarative query language for property graphs created for the NEO4J graph database. So what is actually graph queries in SQL? Usually we know which joins to run in relational database create in a graph query. The number of joins is